It's not illegal if they don't find out. Oh
Oh,
shit, we're
wow.
streaming now. Let me
It's
know.
recorded.
Exactly.
And we're going live stream. So
There's another one on hydrology. You guys did this? Why do I feel
yeah,
like it?
Yeah, we
Okay.
did that
Did that
one.
one.
That
yeah.
was
That
the
was the last one we
Thesian
did.
and isohydral method.
We have one now that we are currently doing that is kind of confusing.
That's a
This
14-page
one, the one
document.
that's just like
Yes, that
roll
one.
off the internet.
Yes.
What the hell is this?
Hold on. What's the 14-page doc? Girl, when I flipped
14
through it, I was
pages.
like, oh my goodness.
You didn't have
Are
to
you
do
good?
that one?
Are we streaming?
Yeah, we are streaming now.
Nice.
It
Okay.
says on YouTube.
Technically advanced.
So you guys want to go through this again, or you're fine? I think you should be fine. That lab was a bit straightforward. Okay. What we can do, Debbie,
I
just
want
pull
you
up
to do frequency, rainfall,
frequency.
frequency,
Oh,
precipitation,
how's
whatever
that?
it's called.
Well, frequency first. Okay. Debbie, can you pull up that document, please? There's some stuff under that you guys didn't learn yet, but that's okay. You can ignore it and use it for later. I'm also following on my phone. Frequency analysis. Okay. So do you guys know what probability means? It's right there on the screen, guys.
Probability is a measure of how likely an event will occur.
Yo. An event, especially of a particular magnitude. So probability is actually a ratio. Probability, when you put a graph, it's typically on the y-axis. Okay. You can scroll down. Okay. So based on the graph on the right, as magnitude increases, event, especially of a particular magnitude. Oh, whoa, that's a lag. I just heard myself in the lag. When you photograph, it's typically on the y-axis. Okay. So if you're not talking, can you mute the mic, please? Because I'm
You
hearing lag
watching
again.
the live stream?
No, I'm not. So based on the graph, so I don't know what that's about. But typically when you have a low magnitude event, the frequency of that occurring is higher, right? And when you have a high magnitude event, the frequency of that reoccurring is lower. Recurring is lower. So if you have, let me just use a basic example, an earthquake, right? Jamaica gets earthquakes a lot. If you have a low magnitude earthquake of about 3 or 2.5, the frequency of that occurring will be greater than if you have an earthquake of, let's say, 7.2. Okay. So Debbie, you can scroll down. Okay, did you guys learn that yet about the types of graphs and skewedness?
What she spoke on and what we learned over recording. Yes.
Okay, you caught yourself. Beautiful. So just tell me if you don't understand, that's okay, but what do you understand what skewedness is and what the different types of graphs are telling you?
I can look at a graph and identify what it is. I just don't think I understand it enough when it comes to like the analysis. Like I know if it's like right-sided skewed, that means the peak is more towards the right of the graph. I just don't know what that means in regards to analysis.
That's so okay. So what that may mean, if we relate that to storm hydrographs now, the peak is to the right. You're going to have a longer lag time. So the time it takes from the rain started falling till it reached the peak. And if the peak is on the left, that means you have a short lag time. So from the time that it started raining to the time that it reached the peak, it'll be shorter. So it's just to help you spatially see what is actually going on. So it's nothing to bust your brain over. So that's that for skewness. You guys can stop me at any point. If you guys want me to send you these two, I can send it to you.
Sweet.
All right, no problem.
Files, we call it, in the chat last week. But we were going to make a Google Drive and put them in there as well.
Okay, so they can just get everything on time. All right, no problem. So I'm just flipping in my notebook now. But you guys, you know the difference between a hazard and vulnerability?
I don't know.
I think is it vulnerability like in regards to, can I throw in the word probability, or how likely an area is susceptible to an event?
Mm-hmm.
And like a hazard is just an event that can happen overall, so it's not subject to a specific, is that what it is? It's not subject to a specific location, so a location can be vulnerable to a hazard? No?
I get what you're saying. You're on the right path, man. You're on the right path.
That's what teachers say all the time. You're not quite there, but you're on the right path, okay?
We're refreshing together, so that's fine, man. So I'm just looking back at certain things. Okay. So you guys did hydrographs and those graphs already, yeah? Because we could go into that, because hydrographs is a whole nother thing. So Debbie, can you bring that up, please? Because this is going to go into something else. You guys don't need to see it.
This? Where?
No, the other document that says hydrographs and base flow separation. Based on the labs I showed you guys earlier, when I put it up to the screen, you guys seem fine with those graphs, so you should be fine with PX curves, rating curves.
Gabrielle, which document is it in?
Hydrographs and base flow separation. That's the title. Oh no, you don't have.
I only have this 3 that you sent.
Darn it. Okay.
And it's in the group.
Wait.
Okay, I'll send it right now.
Wait, they learn about base flow separation?
You mean last year, Oliver?
Yeah, cause I know hydrological modeling. I know hydrological modeling last year. We learned that, you know.
We learned it, man. Okay, so Debbie, I'm sending it right now in the chat. So until that comes up, I'm just going to talk to you guys about that so far. So, you know, you have the physical aspect of it when we're looking at hydrographs and base flow separation. So we need stream gauges, right? We need stream gauges to measure the discharge, the volume of water in the river. And did you guys learn about the setup about that? Because last year what we learned about the actual stage in the river and how it measures the discharge. You learned that, or?
I think she did that at some point, but again.
Okay.
I think she did it. I think I just need to review it for it to stick, but I do think she did it when she was talking about the conditions for it.
Okay. I'm going to tell you some applications now, so you don't feel a little stressed out. So you can measure stream flow data from the river, right? We measure stream flow data to obtain discharge. And from that, you can have things about water supply management, right? So when you have stream flow data and you know about the volume of water in the river, you can know how that affects availability and accessibility of water. Another application of stream flow data is engineering designs. You're going to need to know that so you know how to create dams, roads, bridges. You see how the roads just breaking up right now and everybody just stressed out. Had we used
I'm
some
dead.
stream flow data,
This one is
right?
a
Had we had some stream flow data, we would know how to build all of that. Well, you can scroll down, Debbie. As well as we need stream flow data to help us with flood planning, flood management, early warning systems. So, for example, in Jamaica by the Rio Cobre, we have an early warning system. So, what the Water Resources Authority does is once they realize that the volume of the river is getting to a particular level, they will close the gorge and they'll send off an early warning system to close it off, and people will know to avoid that area. So, they'll also send out press releases to say, oh, don't drive across Flat Bridge right now because the area.
You die.
Oh my gosh, Kimoy. I was just gonna say the areas are likely to be flooded. The last application that I have, and you guys can look up other applications, is ecosystem and recreational management. So, for example, in the rivers, we're going to need to have a certain volume of water so that the little fishes and the other water creatures can survive. So we need to know that. For example, well, no, not that. And for recreation, we're also going to need to know the certain water levels. For example, I have right there the Black River Safari. If we had no river, how would we have a Black River Safari, right? We need to know
We have
the
a
volume
Black
of
River
water.
Safari.
Yes, we do in St.
Hey.
Elizabeth.
Ooh.
Yes, girl.
I don't really live here sometimes, like that. I really don't sometimes.
Yeah. Wow. So Debbie, you can scroll down a bit more. I want one of you, well, not one of you. I'm gonna assign stuff, and you guys just explain what it means. Debbie, explain lag time for me. Morgan, explain.
Why you pick on the biologist? Look how many geologists are
You
here.
do this course, girl. Debbie, explain lag time. Morgan, explain to me what you know about rising limb. Kimoy, explain to me what you know about
Fine, lag time because clearly.
falling limb. Zari, girl, stop. Zari, explain to me what you know about base flow.
You didn't give me one.
Kimoy?
Yes,
Yeah, I said
more
falling
mine.
limb.
I volunteer.
Falling limb. Oh,
So Debbie, what is lag time? I said it earlier as well.
You serious?
Yes, girl.
I'm so sorry.
You can use the graph. Look at the graph too and explain to me.
It is a estimated period of time between when peak rainfall has been achieved to something else, something in correlation with discharge. I don't remember.
What are the arrows between on the graph? Peak rainfall and what?
Peak discharge.
Mm-hmm.
Yeah.
Yeah. So that's the specific other thing it's related to. Okay, cool. So Morgan, I gave you rising limb. You can explain what that means to me.
Just sign out.
Wow.
hello.
Fail.
No, I'm still here. My internet is just trash.
Okay.
Okay, so I guess rise and limb
Mm-hmm.
is like the increase in rainfall or something like that until it can reach its peak discharge.
Okay, cool. Yeah. Yeah. From peak rainfall to peak discharge. And just structure it better. But knowing your lecturer, she may not ask you per se what these are, but you may get a blank storm hydrograph to label. Okay?
Oh yeah,
So,
you did tell us that
Interesting.
last week.
yeah. So Kimoy, falling limb, and then Zari.
Falling limb is represents the time it takes from peak discharge where the river is at the light the river
Go ahead.
falling limb is the time it takes from peak discharge where the river has the most volume from the rainfall until it goes back to normal base flow.
Okay, cool. And Zari, what is normal base flow?
Wait, Zaria's here?
I see her name. Yeah.
Ooh. Yeah.
Hey, connectivity issues, Andy.
Yeah, that's what I
Alright,
was about
cool.
to ask. I know you've been having problems for a while.
Okay. So your base flow, as the name says, like normal is beside it, that is the regular level of the river. So let's say you didn't have a flood event or a storm, that's the regular level that the river would be at. And you can wait, no, don't scroll down yet. Guys, give me at least 3 factors influencing the storm hydrograph. Just think about it.
Watershed.
The shape
Yes.
of the watershed.
Mm-hmm.
Did you just say that?
Yeah.
Don't look at the screen. Okay.
The gradient of the gradient or slope of the area
Mm-hmm.
is
You said shape, slope,
Shape and size.
size. Okay. They're different: size, shape, slope, and storage.
you
All
said
right, that's
3 and you
cool.
just said 4.
Okay, well, okay, that is actually one. That is all on their watershed characteristics. Okay, that's one thing.
I can help you
Yeah.
guys. Finally, I know something.
Wow.
Yes, land use. Ha. Land
The
use affect that.
The other characteristic influencing a storm hydrograph is infiltration characteristics. So that talks about soil and land use cover, right? So you can imagine, and let me even say, okay, so for soil, some, let me say soil, and I don't say rock type, but we're gonna say soil and geology. So some rivers may have rocks that are more porous. Some rivers may have rocks that are impermeable, and that's going to affect the rate of infiltration. Yeah. Land use and cover. If you have vegetation around the banks of the river, the rate of infiltration will be low because the trees will intercept the rainfall. But if you don't really have if you don't really have trees, it's just going to rush into the river, as well as urbanization versus a rural area. For urbanization, you're more than likely to have impermeable rock types. So if you somehow have a river nearby that area, yeah, the water is just going to rush down into that. Whereas in the rural areas where they're not as urbanized, the water has more time to seep into the ground and soak into the ground. So rate of infiltration will be slower. All right. You guys want to give me another characteristic? Okay. You scrolled down. It's not
Sorry,
watersheds. It has many subtopics.
Should I scroll still?
Yeah, you can. Oh darn! It's 2:30.
Oh.
Okay, Oliver, I'm coming. Oliver, you're literally the only geophysics person here. It's so sad. All right. Other factors, climatic factors. What you said, Oliver?
I was saying, it's all right, man. We go and benefit.
Okay, cool. So climatic factors that includes rainfall intensity and pattern, the duration of rainfall, the type of rainfall. Okay, and you can scroll down, Debbie. That was just some further notes I had about rising limb, the crest, and everything. So when you guys get that document, you can look through that further. All right, so boom, we did a hydrograph. You think you guys did well? Yeah.
Woo!
Okay, so Kimo, I already said precipitation. Okay, yeah, we can go to that one because we looked at frequency. So we looked at frequency.
When did we look at frequency?
We did when we're talking about the magnitude
That's it.
and what's vulnerability and those stuff. Yeah.
Oh, yeah.
Yeah.
You know, this not
You would think it would be more information.
right. This
It
is
is. No, it is. Okay, so Debbie, okay, scroll back. Scroll up a little bit. So you see this part? This is more, okay, scroll down a little bit. So I have information about how you calculate the probability of exceedance. But I believe you guys already did a lab about that. So if you want to read through this, you can read through it and you guys seem fine.
With that lab, she didn't really go through much detail on it. She kind of just like said, here it is. There you
Yeah.
go.
Do it.
And then she
Do
came
it.
today saying,
Understand it.
"So where's the work? Did none of you attempt it?" I said,
Kimoy.
Kimoy.
Okay. Okay, I literally have an example right here. So let me follow the steps on the screen. So I have a table here. It gives me the year, the year and the rainfall. So what we have to do is the first step is you sort your data in an ascending or descending order by rainfall values.
What is this, Gabby?
This is how you form your probability of exceedance graph.
Oh, okay.
Okay, so that's your first step, right? I'll show you guys my thingy afterwards. What are these numbers? Oh, okay. So how we did it in lab is that we did it in a descending order. So from the greatest value of rainfall to the lowest. And from that, you rank the data. You rank it from highest to lowest. So the greatest rainfall value, you assign that column 1, and the lowest rainfall value, it can exceed 10. It will have whatever the data set ends at. How you calculate the probability of exceedance is that, what is this again? The formula is R over n plus 1 times 100. Okay, beautiful. I have what these mean. R is the rank. N is the number of samples plus 1. So for example, what I'm looking at, we have 18 things, right? So if I'm looking at the first data set, I would have 1 over 18 plus 1 times 100. That value is your P of X value. So that value is what you're going to put on your y-axis, okay? And you put your rainfall values on the x-axis. So you guys want to see my graph to see an example of what that looks like? Okay, I'll just show you my graph. Well, and there's this graph right here too. Okay. So you should get a curve. So right here, this curve slopes downwards. And you can look at my screen. I hope you can see properly. You guys can see this is an example of another curve. Okay. So if you guys want more practice, this lab example and you calculate it and I see, and I can take a look at it. All right, so that's probability of exceedance. You guys good with that?
Yes.
I think so.
Beautiful. Okay, so Debbie, you can go on to precipitation now. So when you guys learn this in class, it seems way harder than this, like extra complex.
It does, to be honest.
The thing is
dear.
that the way she brings the
Explains it.
information across,
Yeah, I think it's
not
the explanation
clear.
that we don't
It's
understand.
not clear. It's concise but unclear, and then she says it really fast and asks a bunch of questions that she then proceeds to answer herself, as if we already have the knowledge, but we don't.
Okay.
So it comes off as harder than it actually is.
I'm not
Okay.
exactly sure we get in the slides either. I think she wants us to watch the recording because I guess the slides are
Oh,
in
you guys
it.
don't get PowerPoints? Oh,
But I don't
wow.
think I think they stopped posting the PowerPoint. I haven't seen any.
Okay. So, guys, just tell me a little bit about what you know about precipitation so far.
It is rain.
It's rain.
Okay, as in, how does precipitation happen? That's a better question.
Up in the clouds is evaporation. So you would have a warm mass that was created by evaporation. So the heating of water bodies, it would rise. And then by the time it reaches, I don't know which sphere it is, I think it's a troposphere or something, it would start cooling, and then the water molecules would start coming together to form condensation, which would create clouds. And then I don't really know the mechanisms for what would be like creating different types of precipitation, like hail or something. Like depending on the temperature, I don't know, region, something like that. Precipitation falls, water, snow, hail, sleet, whatever, falls to the ground. That would be what's it called?
Types of precipitation.
I don't remember the type of it, but I know that relief rainfall is when the air mass rises because it meets a barrier, like a mountain. Frontal rainfall, is it frontal rainfall? Occurs when you would have one air mass wedged beneath the other. So it can be cold air mass wedges beneath warm air mass and forces it to rise. Or it
You know
could
things,
be,
man, Kim, when you act like you don't know things.
can you say C6 stuff? Or it
Yeah,
could be a air mass that's wedged by a colder air mass. Does have to be warm.
Okay,
Yes.
cool.
Temperature gradient.
So what's important is that you know the types, and convective rainfall. Kingston gets that a lot, so you guys can go over that. A lot of other factors that affect precipitation are topography, which you briefly mentioned that in orographic rainfall, distance from the sea, and atmospheric circulation. Oh dear, I'm seeing your comments. Okay. And wind, you can scroll down. Advantages of rainfall data. Okay. So I'm not sure if you guys got that on assignment, but last year we got my computer. Last year we got our rainfall assignment. So advantages of rainfall data. It will help meteorologists to provide local predictions for respective countries. So for example, in Jamaica, we have our Met office. Yeah. That helps us. They also use that information to create rainfall summaries, drought maps, as well as they have a farmer's bulletin. So if you guys want to see more information on that, you can use that link. So we learned that last year. Advantages of rainfall data. Again, it will help farmers to alter their planting methods. For instance, drought has been affecting Portland, and bushfires are picked up by satellite imagery. So when the farmers know around what time drought occurs, they can alter what they may plant. They may alter their planting techniques for certain crops as well. Another advantage of rainfall data is it will help people in local agencies to know how to distribute water. I hope NWC knows that, but okay. Limitations. One of the limitations is that the map is on an island-wide scale and not on a local scales. So parish by parish, community by community. Because we know that we have our own microclimates within those areas. Alrighty, you can scroll down, Debbie. All right. So that's just examples of rainfall data. We have histograms to represent rainfall data, typically, and you also have a rainfall mass curve. All right, you can scroll down some more. Let me look at my labs. All right. So you guys tell me what you know about these methods, because I want to understand what you know. Anybody wants to tackle the simplest one? The simplest one is the arithmetic mean method. No, okay, I'm gonna pick someone.
What do you say?
I want somebody to explain the arithmetic mean method.
Oh, not it.
Not it. Bro, it's right. All right. Debbie. Yes, I'm calling on you. You do this course, fam.
I was going to do the I understand the isohetal. I don't know if I'm pronouncing it right, but the isohetal one I understand the most.
So you want to explain that one?
Isohetal.
All right. What? Yeah, that.
I'm gonna do Theesian.
I still don't
Okay,
understand
cool.
this one.
I'll go with arithmetic. Guys, that's the simplest one. I'm going back in my book to see what the formula is exactly. Like, what do these?
Shouldn't it be easier for you to explain? We gave you the
But I want to see what the stuff means before I tell you guys.
We need to know the arithmetic method. I thought it was just the isohetal and the Theesian one that we're doing.
It's the simplest one.
As in know it for the exam or know it overall?
Overall.
Oh, I don't know.
Well, I mean for the exam too, but
I know, but she's for sure going to like give us isohetal and Theesian.
we did arithmetic one.
All right. So for time,
not for the lab.
We can probably cut that one out. It's not long, but yeah. Okay. So Debbie, what do you know about isohetal, that method?
I know that it's about scientific guessing. So when you have a specific someone's joining. Sorry. Yeah, when you are using a what you call it, the I word, intervals. So usually like we use intervals of 5. When the different stations are placed between intervals and they don't follow that pattern, you have to draw a curve, giving a best fit curve in quotations to determine where the next interval would be between those locations so that you can estimate the what you call it, the area between the two isoheats, if that made any sense whatsoever.
You guys understand that? That sounded a bit complex to me, but I get it. But you guys understood that? Yes, no, maybe so.
I'll take your silence as a yes. I should be a professor.
All right.
Yeah, you did fit in with Miss Lando.
My gosh, Jesus.
It's the bio brain.
Children.
I don't know how to make it any simpler than that.
Okay, that's okay. So the difference between this and the arithmetic mean method is that this method incorporates, as Debbie said. Yeah.
Someone else join?
So rain gets fractionated in an area by the runoff effect, and rain gauges should be separated by about 10 to 15 meters. So what the isohyets are doing, like Debbie said, they're linking areas of the same rainfall values. Okay, so you have 10, you have 20, you have 30. So why do we need to find out the area? What's the deal with that? Why is that important?
Coverage.
All right, yes. Because see, you may have different, so for example, in the arithmetic mean method point, you just have these different rain gauges here. But right here, you can get a true sense of the rainfall values. Okay. Okay, boom. So you see that example, we actually broke down this in class. So what you're doing is, boy, I wish I remember what these mean. I'm looking at it for me.
Honestly, I don't think like, because this is what she had in her notes. This like the notes for this wasn't an issue. But I felt like the lab that we did was kind of different from what the notes were saying. So I think that's
Boy.
like because they had in volume and all them extra
Wait,
stuff.
the lab, that was the 14-page document?
No, this was a different lab.
Before that.
Okay, Debbie, do you have that lab? Can you bring up that lab?
Why? I should. Let me check.
Okay.
I'm not.
So you guys understand what? No, that's beautiful. Kimoy, we didn't forget you. You can explain season soon.
Oh, I just came back from. Okay, so Thesan polygon method is using geometric lines to find out the area, because you'll have rain gauges on the map which will have a precipitation value. However, you need to figure out the entire map, so you can't just go off of one base. So what you would do is you would draw lines connecting the rain gauges to each other, the rain gauge stations, and then you would find the perpendicular bisector. So I do it by using my protractor to draw arches and draw a straight line, or you can measure the line in between it and divide it by half. Then you would use your compass, or you could use a right angled ruler to draw it to a right angle, and you extend the line. So then by the time you extend the lines for all of the lines connecting the rain gauges, they should intersect at geometric angles to each other. Like by the time you do it, you'll see it adds up, it matches up nicely, and you wouldn't have any awkward spaces. So then you would outline those lines, and by the time you're done, you should have the lines forming a polygon around each rain gauge to compass the area surrounding the precipitation, the rain gauge station. So then you can assign the precipitation value for that station for the entire area. So by the time you count up the area for each polygon and assign it to the precipitation value, you can find out the precipitation value for the entire area, and then the weighted precipitation value for the entire watershed by the time you add up all of the polygons to get the combined area.
Okay, cool. 7 pages. Yeah, that's the lab I was just showing my graph for. What was the issue with this? Because my lab right now is not 7 pages, but what was the issue with this lab, guys? So for example, for us, what she told us to cross out, to cross out corrected area for polygon, corrected percentage for polygon. And we didn't do the adjusted precipitation column. So you guys are good with calculating the first part?
Yeah. I mean, she went through this because people actually attempted it. So she gave us information for it. I didn't have an issue, but I think Morgan had an issue with it.
Okay, what you had an issue with exactly, Morgan?
It was the volume.
The volume?
It was a little bit unsure to me.
Oh, that part? For us, I see a note on my lab. I put, you multiply the area by station rainfall. So let me see, I have my calculator here.
I think the issue it came when is that, they have two different, what do you call those? millimeters and kilometers. They call those things.
Yeah,
So they
that
have
was
two different.
was saying two different things at
I
once.
mean, mathematically, you can't multiply without converting, but then they say, okay, let's multipy it and then use the millimeter. So I'm like, yeah,
Yeah,
we're changing the math
right.
now. That's what we're doing.
I get what you're saying in terms of you didn't have to convert. Sometimes I realize if I convert to for
They,
certain things, it's just way off.
they say
But
we
then the
didn't.
graph
They
ends
say
up
we're not
okay.
supposed to convert. They just multiplied it and then just use the millimeter
Yeah.
for the volume, which
So
I didn't get because I thought in order to multiply, you have to have the same.
units.
Yes.
I get you, I get you. In this case, you don't have to. So for example, for the first column for volume, you should get 15. For the second one, you should get 1.75 multiplied by 26, 45.5 millimeters. Okay, so just to clear that up, you don't have to convert for that. Okay, you can scroll down, Debbie.
Why?
Why?
It's like define the laws of mathematics.
7 pages though. Okay. All right, 2:52. Wow, time flew, guys. Yeah.
And
But you
guys,
guys
when you're
feel a
having
bit
fun and
better?
learning. Yes.
Okay. Is this lab graded for you guys though?
Not to my knowledge. Only one she graded was one that we did with Google Earth.
Oh,
Oh yeah.
all right. So if you want to see my value for the volume, Morgan, just let me know.
Alrighty.
Yeah, we're gonna have to practice another time, Oliver. Sorry about that. Okay. Explain. Listen, if you are like me and you need visual aids, you can look at the document. Okay. Oh, scroll down for a sec, please, Debbie. I'm looking, it says area weighted methods. There are some points that look important. Okay, so just some points to note for your area weighted methods. The arithmetic mean method does not incorporate area into the formula. The A is literally not there. The arithmetic mean method overestimates rainfalls that enters a particular data. Okay. Limitations for the isopietal and Thiessen polygon methods. Pretend you guys don't see anything on the screen. Tell me some limitations of those methods. Oh, see? What? Alright, scroll back down. Scroll back down. Okay. So new isohyets have to be made for each rainfall event. So that's a limitation. Another limitation is that the Thiessen polygon does not account for topographic influences. Okay? And both methods cannot be used if there's only one rainfall station. All right, guys? So yeah, we looked at hydrographs, we looked at frequency, we looked at, what's this? Watershed characteristics. We looked at precipitation. So guys, be confident into going into your exams, and if you have anything else, let me know. Okay?
Yay.
Thank you, Prezi.
No problem.
Thank you.
And as Debbie said, you guys will get...
Merci beaucoup.
No problem. As Debbie said, you guys will get these documents. Just don't copy paste, as Doc will say. All right, bye, Oliver. Wow, you had fun. That's great. Okay, enjoy the rest of your evening.
Are we still gonna play the quiz something?
We
Oh,
can.
yeah,
You have
play
questions in
Kahoot.
there?
I didn't get to finish the quiz, but we can play Kahoot if y'all got another device.
Oh. Guys, I'm gonna
What
have
is
to run
Kahoot?
over to another meeting at 3, but if you guys stay, you'll be fine, okay?
Yes.
All right.
We don't
I
need your chaperoning.
Wow, okay.
Bye.
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 So I don't know if you guys want to stop
Bye.
the recording now or if you want your game name.
Yeah, let's stop the recording because
I'm gonna win.
the hour is actually up. So
Okay, bye guys. I'm going to model you in.
Then
Hashtag plug.